In this video here, we're going to be looking at square roots and perfect squares. So some of our targets is, do you have the ability to list the perfect squares, which we'll discuss? Do you have the ability to find squares of roots and fractions? And do you have the ability to find roots of decimals? So when we're dealing with a perfect square is a number such as 36, which means 6 times 6 is 6, and a perfect square is when these numbers are not decimals. So we can do that when we're doing fractions as well, and we can actually take perfect squares when they're decimals as well. So a perfect square is just when the numbers are extremely accurate. And what I mean by that is, for example, 0.25 can be a good answer because it's nice, it's neat, it's only 2 decimal places. So those are things what I mean accurate. So let's look at number 4 and we'll see where we get. It says list all the whole numbers, again whole numbers, that are perfect squares between 1 and 100. The easiest way to do that is starting with the number 1. 1 times 1 is 1, so 1's a perfect square. 2 times 2 is 4, so 4 is a perfect square. And you just keep going until you get to the number 100. Now, it's not going to be 100 times 100. It's going to be what number times what number will give me something closest to 100. Okay, so number 5 is where it gets kind of challenging. The easiest thing to do is not to use a calculator. Again, we want you to conceptually understand what we're doing here, not just plug this into a calculator and get an answer. So what we're doing here is, for example, for letter A, the square root of 0.36 can be written as a fraction inside the radicand, which is tenths, hundredths, which is 36 over 100, which can be written as 6 over 10 times 6 over 10, because 6 times 6 is 36, and 10 times 10 is 100. So therefore, we could write it as 6 over 10 squared, and we know that a square and a square root are opposites, and they cancel each other out. So my answer is 6/10 or 3/5 if I'm reducing. So that's how we're going to be handling a lot of these. So we're going to look for the fraction component of it. Once we have the fraction, then we can just look for the perfect squares according to that. So let's erase one, we'll do a couple more, and then we'll get to different examples. So let's do D. D is the square root of 0.16, which can be written as 16 over 100, which then can be written as 4 over 10 times 4 over 10, which is 4 over 10 squared. Square root cancels a square, minus is 4 over 10, and you reduce answer of 2 over 5. Okay? Let's do a decimal one. Or, sorry, a fraction one. Square root of 25 over 9 can be written as 5 times 3, or 5 over 3 and 5 over 3, which then can be written as 5 over 3 squared, and my square root gets canceled. In this situation, I'd probably leave it like that. There's no sense to convert that into a mixed number, but if you want to, you can. Okay, so that's how you're going to do number 5. Number 6, list all the whole numbers from 101 to 400. So 10 times 10 is 100, so it can't be 10 because that would be 100. So the first number would be 11 times 11, which would be 121. 12 times 12, which is They want to list the perfect square. So 12 times 12 is 144 until you get up to 400. I think we actually did this one wrong too. No, we did that right. We want to go 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, all the way up to 100. So I'm not sure if we showed that right or not. I don't remember. Okay, so number 7. The square root of 169 over 16 can be written as 13 over 4 times 13 over 4, which then can be written as 13 over 4 squared. This writing it as the squared part here conceptually shows that you know why 13 over 4 is your answer, because you're writing it as 13 over 4 times 13 over 4, which then is squared, and to get rid of the square root symbol, we have a square. These two are opposite processes. They cancel out. You must show your work. You just can't use a calculator for this. And the rest, you're going to look for perfect squares. Again, we did number 6 because all of these numbers here seem to be all of these numbers here. So it makes sense that we did number 6. Now let's look at letter G, because they get a little bit more challenging when the numbers are square root of 0.0121 is the exact same as the square root of 121 over tenths, 100, 1,000, 10,000. Which is the same as 11 times 100 times 11 times 100. So I can then write that as 11 square root cancels a square. And I convert that back into a decimal. Okay, so that's how you can handle that first page there. Keeping in mind, all of these numbers are perfect squares. You just have to write them as a fraction. Find out, usually the numbers are going to be, they're only going to be work for perfect squares if the number on the bottom is 100, which is 10 times 10, or 10,000, which is 100 times 100. If the number happened to be 1,000, there's no number times no number that's going to give me 1,000. That's a perfect square. So be cautious with numbers like that. And on this page here, it's the same idea. Which one of these are perfect squares? And give you a reason. They're perfect squares if I can write them as a number times itself. So the square root of 12 is the same as square root of 12 over 100, which is the same as a number over 10, right, times the number over 10. There's no number times any number that's going to give me a nice number here and here. So therefore, this one is not a perfect square because I cannot write it as a square of two numbers. What I mean by that, a square of two numbers is like this one. I can write that as 81 over 100, which is the same as 9 over 10 times 9 over 10, which is the same as 9 over 10 squared. This is a square of two numbers. The numbers are the same. Therefore, I can write it as a perfect square. Therefore, it is a perfect square. There's some tricky ones here. For example, this one here, 8 over 50. It doesn't appear to be, but I can reduce this by 2 to get 4 over 25, which is now 2 over 5 squared. Square root cancels a square. This is a perfect square. The reason is I can write it as a number squared. Okay, I hope that helped. Number 9, play with a bit, see what you can come up with, and we'll deal with that more when we deal with numbers that aren't perfect squares.